there, and welcome to the beginning of Foundations Pre-Calculus Math 10. I always have to stop because I forget about pre-calculus all the time. Anyway, so this is a math that gets you ready for Foundations 20 and 30 in grade 12. And we're starting out with factoring and prime factoring, which for most of you is going to be a review from first semester. So I thought I would start it out easy. Okay, so I haven't done videos in a while, so I just panicked. It said, what's a prime number? And I'm like, I don't know. Or rather, I don't know how to say it in a pretty way. So I paused it, found the answer that I want, so I'll be able to tell you. So you should know from last semester. Hopefully you wrote in something already. So prime number, and I'm going to see me do this because I'm copying off another sheet, but it's a really nice definition. I got it from one of the students. It's a whole number So first of all, that means no fractions, no decimals, a whole number like 0, 1, 2, 3, 4, greater than 1. That only has two factors. One and itself. Okay, so the deal is, and I just take this as gospel, I don't worry about the why. 1 is not considered to be a prime number. It's got something to do with like higher math levels where they have some rules. And if 1 is prime, considered prime, then the rules don't work. But if they say, hey, as long as we don't include 1, they work like a charm. So 1 is not considered to be prime. It's also pretty useless in the stuff we're doing. So I'm okay with that. So I want you to write out the prime numbers from 2 to 100. So 2, right? Because the only way to get 2 is 2 times 1. And then 3, because 3 only has 2 factors. Oh my goodness, it's a snowy day and they're sending us home, but I'm going to finish the video. Okay. So 2, 3, the next number is 4, but I'm going to put it up here. 4, yes, 1 times 4 is 4. We all know that. But also, 4 is equal to 2 times 2. So that means not prime. And I don't know if you can see the video, so we'll move that out of the way. The fancy schmancy word that I only learned about 5 years ago, it's called a composite number. Now, so 4 doesn't work. 5 works. Okay, not gonna lie. I can go maybe up to 20-ish, and then I have to think. So, oh, well, you can't see that very well. This is my friend Google. Let's see if I can get a better one. Ha. There we go. I just said, like, hey, Google, give me a list of prime numbers from 1 to 100. So I'm just going to pause this video because you really don't need me narrating. That's all right, though. Okay, there we go. There's a whole list. This over so you can see it all. It's not something that you need to memorize. What I usually suggest is that students write it on the top of their formula sheet before they write their exam. And heck, a lot of the time it's also on my on the whiteboard in the classroom when we're doing this section. Okay, so next thing, explain why 7 is prime and 8 is not. Well, you could say because 7's in my list of prime numbers and 8 is not, but that's not going to get you anywhere. So when we look at 7, the only 2 numbers that multiply together to give me 7 is 1 times 7. 7 times 1 is the same thing, so that doesn't count. But when we look at 8, we of course got 1 times 8, but there's also 4 times 2. And I mean, we can flip the factors and it's still the same pair. So prime, 1 set of factors, not prime, 2 set of factors. And if I did, let's say, for example, 16, we have 1 times 16, 2 times 8, and 4 times 4. So it doesn't matter whether it's sets of factors, 3 factors, whatever, don't care. As long as it's more than just that single pair, you're good. And a composite number is the opposite of prime. Remember, I told you there was a fancy word for it. But that's really, to be honest, a terrible definition, simply because, well, what if you don't remember what prime is? So, has more than one set of factors. And to be honest with you, on a test, I would probably then put 8 or 16 or some other set to show that I know what's the word I want? I know the definition, but I also want to be able to say, excuse me, and I can prove it to you. Like, here's an example. Oh, there we go. Okay, cool. So prime factorization. This entire chapter, although very short, requires you to do prime factorization. And it's a great way to get good at your multiplication table. And you know what? You're going to learn some tricks along the way. So none of these numbers is prime, I don't think. Oh, wait a minute. Trick question. I recognized it. Look, 37. 37. Yeah, can't factor out because there's no prime, no numbers. The only factors are 1 and 37. Okay, back to what we're supposed to do. So when we do this, and I think this is the first video I've done on prime factorization, so I want to do a really good job. You need to think of 2 numbers that multiply together to give you this top number. You can't use 1, okay? So this is 24. So I'm going to do this at least 2 different ways. So I know that that's 4 times 6. Because 4 times 6 is 24. But these numbers aren't prime. Okay, if you're not sure, you can always go back to your list. Oh, wait a minute. I turn my phone back on. Ha, there. I'll put it over here. Okay. 4 and 6 aren't in this on this list, so I must be able to break them down again. 2 and 2 and 2 and 3. And ta-da! You will notice that 2 and 3 are on my list of prime numbers, so we're done. You're done when this line gives you all prime numbers. Now, we should check, because I said 4 times 6 is 24. I should be able to go 2 times 2 is 4, times 2 is 8, times 3 is 24. So every time you multiply a line, it should always go back to this top number. Now, the next part, is left over from last semester. This we did as practice, and then for the rest of the section, we didn't really use it because it wasn't helpful. So ascending means going up. So this is the 2's first and the 3. An exponential form means 2, and there's 3 of them. So 2 is my base, and there's 3. That's the exponent. It's not this 3. That's just dumb luck, but there's 3 there. And then we use a dot, because Mark the tutor got on me to make sure I put a dot there. And then the 3. Ta-da. Yeah. I want to show you. I'm going to squish it over on this side. Oh, hold on. I hope this works. Hope you can see it. I just wanted to do it in a different color. I don't want to brag, but I'm pretty good at my multiplication table. So I knew it's 4 times 6. Made it pretty easy. If you're having one of those bad days, any number that ends in 0, 2, 4, 6, or 8 is going to be divisible by 2. So I know this is an even number. So I know I can go 2 and 12. And I'm going to bring my 2 down. 12 is not on my list of primes, so I can break it down. I know that's 2 times 6, like that. So 2 comes down, it's prime. 2 comes down, it's prime. And this breaks into 3 and 2. But 1, 2, 3. So there's 2's and there's 3 of them and a 3. The cool thing is it doesn't really matter where you start with these. That final line. So when I write this the correct way, 1, 2, 3 2's, the final answer comes out the same. Usually, or for the rest of this chapter, that's what I need, the form I need it in. I don't need it to be exponential, but I need it in ascending, starting at the smallest and going bigger. It makes life easier. All right. Where am I going to put my rules? I didn't leave room. I'm over here. That's very useful. Sorry, it's been a while since I've done this. Okay, so what I wrote over there is this is my quick and dirty set of rules. If it ends in 0, 2, 4, 6, 8, then it's an even number and you can divide it by 2. I kind of wrote that in weird order. I'm going to put it the other way. Or the next one ends in 0. Come on. I'm like Dora the Explorer, yell at the TV, yell at the video. Yeah, we can divide it by 10. Just save some time. Because it ends in a 0, it's also divisible by 2, but the bigger numbers that I start with when I divide, the simpler it's going to be. Sorry, I got stuck on my blue pen there. So this one is going to be 50 and 10. So 50 times 10 is 500. Now, those are not prime. So away we go. And this is 5 times 10. And this is 2 times 5. So be careful. This is always multiplication. I don't want to jinx you, but so often students will see 10 and they'll put 5 and 5. Not adding. This is all about multiplying. So 5 times 10 is 50, times 2 is 100, times 5 is 500. So every single line should all work out. 5 is prime. I'll bring that down. 10 I can break up. And these are both prime. So we're good. So now, whoops, kind of got the order there. I want the 2's first. So there's 2 of them. Actually, I'm going to do 2 lines. 2 times 2 times 5 times 5. All I did there was just put them in order rather than trying to count and put them in order at the same time. And I'm going to double check because I hate being wrong. 2 times 2 is 4, times 5 is 20, times 5 is 100, times 5 more. Oh, that'd be 500. So we're golden. And you can also check those on your calculator. So I have a base of 2, and there's 2 of them. And now I have a base of 5. So that's the number I multiplied. And I have 3. And ta-da, there we go. I think at this point, you should pause the video and do the rest. It's pretty easy. I trust you. Pause the video. Okay, here we go. 81. I have a rule. I'm not going to write it down, but it's one that works. If you add the numbers together, so 8 plus 1 is 9. And if that sum is divisible by 3, the whole thing's divisible by 3. It's not that great a rule. But if you get stuck, get my handy dandy calculator out here. So I'm going to pretend I have no clue what divides into 81. What you do is you start with this great prime number list. and you just go. So 81 divided by 2. That didn't turn out as a whole number, so 2 is not a factor. 81 divided by 3. Okay, there we go. 3 and 27. And 90% of the time, once you just divide a prime number out, the numbers get small enough so that you don't have to worry about it anymore. But let's just say I'm having a bad day. I have no idea what multiplied together gives me 27, or if there is anything at all. So 27 divided by 2. Nope. 27 divided by 3. Oh, there we go. Are you yelling at me? You should be yelling at me. That should have been a 3. There's no reason that didn't come down as a 3. So this is 3 and 9. So 3 and 3 and 3 and 3. Okay, don't have to put that in order. Nope, nope, nope. It's already there. So our base number we are multiplying is a 3, and there's 4 of them. All right, 26, I can use my rule. It ends in a 6, or it's an even number. So it's going to be 2 times something, and it's 2 times 13. And if we check our list, 13 is a prime number. So done. So sometimes they're long, somewhat painful. Sometimes they're super easy. And sometimes they're sneaky because they're prime numbers. All right, 63. I'm going to pretend I have no idea. 63 divided by 2. I don't know why I keep doing divide by 2. You guys are smart. If you know if a number is odd or even. And 63 is not a number, so don't even bother. 63 divided by 3. Oh, there we go. 3 times 21. So 3 comes down. 21 is 3 times 7. Wow, that was easy. So putting it into ascending exponential form. Okay, so I got 3 squared times 7. There we go. All right, 98. Oh, I know that's going to, I don't know what that is. Okay, so 98, but I know it's going to divide by 2 evenly. Oh, 2 times 49. I don't know if 49 is prime. If only there was a place to look. So look up here, look on your formula sheet, go 43, 47. Yeah, apparently it's not prime. So that won't work. All right. Let's do this. 49 divided by 2. Nope. 49 divided by 3. Nope. 49. Okay, again, there's no use dividing by 4. It's not prime. So my next prime number is 5. Whoops. 49 divided by 5. I know that's not going to work. 6 isn't. 49. So let's try 7. Sweet. There we go. 7 times 7 times 2. There we are. It's in happy little order there. So we're going to go 2 times, please, times 7 squared. See, this isn't that bad. Until I give you a great big number like 1200. Well, as I said it, let me just pick it down a little bit. Oops, wrong way. It's 1200. So I can just say 12 times 100. That's an easy way to break down. 12 times 100. 3 times 4. And again, you could have done 120 times 10. You could have done 2 times 600. Lots of things. There's lots of ways. 10 times 10. 3 is prime. A 2 and a 2. 10 is a 2 and a 5. And another 2 and 5. Okay, that got messy. So 1, 2, 1, 2, 3. Okay, there's 4 of them. And then there's a 3. And then there's 2 5s. So 2 to the 4th times 3 times 5 squared. Ta-da! There we go. Prime number. All prime numbers down here. I'm going to try 1200. I hope I'll have room if I do it over here. So we can pretend I'm having an exceptionally bad day. And all I remember is, hey, it's an even number. It'll divide by 2. So 2 times 600. Good. 2's prime. This is going to be 2 times 300. 2 times 2 times 2 150. I'm so running out of room. 2, 2, 2, 2. Okay, sorry if I messed you up by doing that. It's just, I just worried I'm running out of time. Or space. 2, 2, 2, 2. That is not divisible by 2. I know. That's 3 times 25. Still not done. 2, 2, 2, 2, 3, and 5 times 5, which is exactly what we had over there. And so my point is I got done in 1, 2, 3 rows. This way is 1, 2, 3, 4, 5, 6 rows. But maths are still the same. So don't worry if, oh, I got to get the best set of numbers so it happens fastest. No, not really. I have some students I've seen that just do 2 every time until they can't anymore. And it's like, it's just easy. And it doesn't bother them at all. So this whoop, goes over there. So thank you for joining me for the very first video of this section. Bye. Have a lovely day.